And so we are going to be learning to understand systems of equations. So when we're talking about systems, we're talking about how two lines are going to be interacting with each other. So when we've got the two simultaneous equations with two variables, and they are crossing one point. So when it's only crossing at one point, straight away we know that the gradients of the two lines are different. They are not the same. If we have two lines that are not going to meet at all, then we know that the gradient must be identical because they will never meet. But we also need to know that even though the gradient is the same, the y-intercept, oops, the y-intercept is different. That's the key difference to the next one. So here, when we've got two lines that are completely overlapping at every single point along the line, the gradient is the same, the y-intercept is the same. The only thing is that it looks different, but in reality, it's the identical same equation. So let's look at this question. Determine the value of k for which the following simultaneous equations have a unique solution. So the first thing I'm going to do with these two formulas, these two equations, x plus 3ky equals 2 and k minus 1 in brackets x minus 1 equals negative 6y. So the first thing I would be doing is getting them straight away into y equals mx plus c form. So let's put the first equation together. So the first equation is x plus 3ky equals 2. I will be taking away x on both sides, and that will give me 3ky equals 2 minus x. And then to get y by itself, I'm going to divide by 3k. But that means dividing each term by 3k. So it gives me y is equal to 1 over 3k x plus 2 over 3k. Let's look at the second equation. So k minus 1 in brackets x minus 1 is equal to negative 6y. So the first thing that I would be doing is just dividing everything by negative 6. So that will give me y is equal to k minus 1 in brackets over negative 6, x minus 1 over 6. So now we've got our two equations that are in y equals mx plus c form. Now, the main thing we need to be focusing on is identifying the gradient. So when we're looking at simultaneous, we're really just focusing on simultaneous equations for the gradient, which means I am only caring about negative 1 over 3k and k minus 1 over negative 6. When we're saying they have a unique solution, it means there's only one solution, so the gradients cannot be the same. So now I've made them equal. The next thing I'm going to do is times both sides by negative 6 and times both sides by 3k. By doing that, this and that cancels out, and this and that cancels out. And that leaves me with negative 6 times negative 1, which will just be 6, and 3k in brackets k minus 1. So the next step is I'm going to expand my brackets. So I've got 3k times k and 3k times negative 1. 3k times k is 3k squared. Take away 3k. We're going to get 6 to the other side to make it equal 0. And this straight away helps me see it more as a quadratic to find the values for k. Again, I can see that with A, B, and C, they all have 3 in common. So I'm going to factor out the 3. So should be there. So if now I factored out the 3, or I could say I'm dividing by 3 because equal to 0, it will be k squared minus k minus 2. This is the part I just jumped quickly because I saw straight away that the two numbers that times together to equal -2 and add up together to equal -1 must be a 2 and a 1, and I just need one negative, which would have been -2. So that tells me straight away that it would have just been if 0 equals 3 on the outside, k plus 1, and k minus 2. This gives me my two k values of k is equal to -1 and k is equal to 2. Because us, like I said before, when we're identifying a unique solution, gradient cannot be equal for a unique solution. Therefore, the simultaneous equations have a unique solution that for k is all real numbers except for when it's 2 and when it's -1. So this question is to determine the value of m for which the following simultaneous equations have an infinitely many solutions. So the first thing, again, we need to do is we need to get them both into y equals mx plus c form. So the first thing I'm going to do with the first question, I'm just going to write it down, mx minus 2y is equal to 4. Then to get y by itself, I'm just going to first take mx to the other side. So I've got -2y is equal to 4 minus mx, and then I'll be dividing by -2. That will leave y by itself. And 4 divided by -2 is -2, and negative mx divided by -2 is is a positive, but it'll be still mx over 2, or m over 2x. If we look at the second equation, I've got x plus m minus 3y is equal to m. The first thing I'll be doing is getting x to the other side. That means I'm taking x away. The second, to get y by itself, I'm dividing by m minus 3. So each of the terms was divided by the same amount. I'm just going to rewrite it now, but I'm going to rewrite it so x is outside the fraction. So that's meaning that I put this here, so that will be -1 over m take away 3 x. Now I've done that, it makes it easier for me to visualize and see. So because it's here it says infinitely many solutions, there's two things we need. We need our gradient to be the same, and we also need our y-intercept to be the same. So that means I'm going to look at the equations for the y-intercept. So straight away here, I've got -2, and I've got m over m minus 3. So the next part is I'm going to get rid of the fraction, so I'm going to times everything by m minus 3, and that will give me 2 in brackets m minus 3 is equal to m. I will expand my brackets, so that means I'm going -2 times m is -2m, and -2 times -3 is +6. The next part is I'll be adding 2m to both sides to get m to one side, and that will give me 3m equals 6, which m will then equal 2. I'm going to then check with my gradient just to make sure that m equals 2 will make my gradient the same. So if I look at the first gradient is m over 2. I'm just going to plug 2 into it, so 2 over 2 will give me 1. If I look at my second rule, m2 is -1 over m minus 3. Again, I'm just going to plug 2 into it for m. So that means 2 take away 3 is -1. -1 over -1 is 1. So my gradient is the same, which means I know at this value, I've got infinitely many solutions. So we're going to determine the values of m and n for which the equations below have a unique solution, b an infinite number of solutions, and c no solutions. My equations are 3x plus 2y is equal to -1, and mx plus 4y is equal to n. So the first step is we are going to, again, turn everything into y equals mx plus c form, because when we're talking about linear, to look at unique solutions, infinite solutions, and no solutions, we're really focusing on an understanding of gradient. So first equation is 3x plus 2y is equal to -1. The next step is I will be taking away 3x from both sides, and that will give me y only on one side. To get y completely by itself, I need to half everything, so divide every term by 2, which will give me -3 over 2x minus a half. If I do that with my second equation, I've got mx plus 4y equals n. The next step is I will take my x's to one side, so I'll take mx to the other side. So that gives me 4y is equal to -mx plus n. And to get y by itself, I divide everything by 4, which gives me y equals -m over 4, x plus n over 4. The next step is we need to identify the gradient. So just remember, for A, it says a unique solution. So that means the gradient is not the same. So that's the key part that we need to focus on. So I'm going to look at my gradient. So straight away, I can see my gradient is -3 over 2 and -m over 4. So I'll make them equal to each other. I will then get m by itself. So I'm going to times both sides by 4, and that will give me negative m is equal to -12 over 2. -12 over 2 will be -6, but I'll just cancel out the negatives and it will give me m equals 6. So that means because we're looking at identifying solutions for unique, uh, identify solution for unique solutions. So that means my gradient cannot equal 6. So it can be any other number, which means it'll be all real numbers except for 6. In terms of n, for this, it doesn't really matter what n is. So again, n will be all real numbers. If we're talking about this part 2, which is infinite number of solutions, well, that means we know the gradient must be the same, but also um, the y-intercept must be the same. So that means that we're talking about the y-intercept. We're going to create an equation, as we do it in blue, that focuses around our y-intercept. So -1/2 and n over 4. So we'll make them equal each other. Again, to get n by itself, I'm going to times both sides by 4, and that will give me n is equal to -4 over 2, and that simplifies to -2. So for infinite solutions, the y-intercept needs to be the same, so it will be n must be -1/2, and our gradient must be the same, so we know m must be 6. The final part is no solutions. So in terms of no solutions, it must be a parallel line, which means the gradient must be 6, but the y-intercept can't be the same, so it can't be -2. This is where it will be m is equal to 6 and n is equal to all real numbers except for -2.